Hello students, welcome back to Organic Embers YouTube channel. In this video, I am going to explain to you about a reaction intermediate called as carbene. Then we will see what sort of reaction carbenes do undergo. First, what are carbenes? Carbenes are the reaction intermediates formed during the course of reaction which are highly reactive. How do we represent carbene? The carbene is a divalent with 2 electrons on it. Okay, so it is having 2 bonds and 2 electrons. So around the carbon we have 6 electrons. So in order to gain the octet configuration, it needs 2 more electrons. That means what? It is deficit of 2 electrons, hence it can act as an electrophile. During the reactions, it acts as an electrophile, means what? It is electron deficient species. Alright, how these carbenes can be formed? The carbenes can be formed by using haloforms like chloroform, bromoform, iodoform, etc. Let's use bromoform. What is bromoform? There are 3 bromine on the carbon, right? And then there is a hydrogen. This bromoform is treated with a strong base like potassium tertiary butoxide. So I am going to give you the structure of this tertiary butoxide. See here, it is attached to 3 methyl groups. Therefore it is tertiary butyl, and oxygen is there, therefore O, and it will carry negative charge as it is attached to potassium, which is a counter ion, that is K+. So this is written as TBU. So that is what is written here. Tertiary butyl oxygen potassium, tertiary butoxide. This acts as a strong base. What strong base does? It will abstract the proton. So that means what? Hydrogen will go as H+. What about its bonding electrons? The bonding electrons are given to the carbon. So what we have done so far, we have removed hydrogen which goes as H+, right? And what about the bromine here? You write that bromine here. And what about this bromine? You write that as well. Now what about this bromine? This bromine goes as a bromide. What is bromide? Br-. It takes the bonding electrons, as bromine is electron negative. It withdraws electron and it will leave as bromide ion. So that's why the carbon here is divalent, because it is attached to 2 bromine, and you see the hydrogen is giving its electron to the carbon. That's why it is having 2 electron. So what we have generated here is a carbene, that is the reaction intermediate. Students, remember, these are highly reactive species. That means they are very short-lived. That means you can't store them. They have to undergo reaction immediately. So now let's see what sort of reaction this carbene will undergo. So you can see it is reacting with a cyclic molecule. What is this cyclic molecule? It's a cyclopentane, because there are 5 carbon, and you see there are 2 double bonds. Therefore it's a diene, cyclopentadiene. That is the molecule which is reacting with our carbene. Although carbene looks like it is having 2 excess electron, but it is not. It is deficit of 2 electron, as I told earlier. So what it does is it will add to the double bond. It acts as a kind of double radical, and it's going to get added to the double bond here like this. Right? This is also called as insertion reaction, because it's going to get inserted in the double bond. So how it happens? Let's see here. This is the new bond formed between carbon and carbon. What about the bromine? It is as it is, like this. It is as it is, right? Now the formed product is a tricyclic. That means there are 3 carbons, right? Like a cyclopropane, and this cyclopropane is not so stable due to the ring strain. So this has to open up. So how this molecule will open up? Let me show this step by step. The hydrogen here present is slightly acidic in nature and we already have a base. So what it does is it will go as a proton, right? And the electrons will shift here. Actually all this happens in one step, okay? But if you don't understand, I am going to write this in step by step. So see here, the electrons will shift here, right? This carbon will become pentavalent. How so? 2 bonds here, 3, right? And see here, there is already one hydrogen, right? There will be hydrogen here, so it will become pentavalent, so not stable. Immediately it has to break the bond. Where it will break the bond? This is the bond which is going to break. So now let's rewrite. I'll start from here. 1 2 3, not changed. Let's write down that as it is. 1 2 3, between 2 and 3 there is a double bond. Now look at this. This is our 4th carbon where the electrons are shifting, so I'm going to write it as negative charge. And this is the carbon here, right? It is attached to 2 bromines here, bromine and a bromine. And what about this carbon? It is the one which is present here, and you see there is a double bond formed over here and the hydrogen is still there as it is. Now look at this. This can form a aromatic molecule by undergoing a kind of elimination. The double bond is formed here so that the bromine will get eliminated. And look at this, out of 2 bromines, only one is being eliminated. And what happens here? The double bond is formed over here and this bromine is as it is, like this, right? We got alternative single double. That means what? The formed molecule is aromatic molecule. This is the driving force which makes this molecule to open up. This is also called as ring expansion reaction, because whatever the rings were there earlier, 5 membered, 3 membered, they are not stable. When they open up, they formed a stable 6 membered aromatic molecule. That is the driving force. And what is the final product we got here? The final product we got here is bromobenzene. Therefore the right option is option D. This is one way of doing the series of reactions, right? The other way of finding the right answer for this particular question is by eliminating the options. See, we have 3 bromine, so our product must have at least 1 bromine. In option C, there is no bromine at all, so you can eliminate that first. Now, look at A and B, they have phenol. There is no source of introducing OH on the ring, right? Then how come we will get OH? So that is also not possible. So the only possibility is formation of bromobenzene. You can choose the right answer this way as well. I hope you have understood this question, and if you have not, you can always ask about this question or any other question in the comment section. Thank you for watching this video. Until next time.